Salt analysis. Aim: to detect a cation and an anion in the given salt. Click here to view the apparatus. Click here to view the chemical compounds. Click on Workspace to hide the rack. Click here to view the experiment details. Click here to view the procedure to detect anion and cation. Click here to reset the whole experiment. Click and drag the apparatus to Workspace. Click a suitable chemical component and drag it on the test tube to pour. If the chosen solution is correct, then the system will show green color and allow you to pour the content, otherwise it will show red. In order to choose the exact quantity of compound or solution, drag and leave the slider to pour. Let us perform salt analysis. First step is to detect an anion. As per the procedure in the procedure table, take a test tube and add 0.1 gram of salt to it. Add 1 or 2 ml of dilute sulfuric acid to it and observe the change. Since there is no change, heat the content of test tube. There is no gas evolved after heating, hence go for step 2, that is preliminary test with concentrated sulfuric acid by clicking Perform Next Test. Take a test tube, add 0.1 gram of salt to it. Add 3 to 4 drops of concentrated sulfuric acid to it and observe the change. Colorless gas with pungent smell is observed. Now bring the rod dipped in ammonium hydroxide near the mouth of test tube. Dense fumes are observed. This shows the chloride ions may present. The detection of anion is complete. Click here to perform confirmatory test. Take a test tube, add 0.1 gram of salt to it. Add a pinch of manganese dioxide and 3 to 4 drops of concentrated sulfuric acid. Heat the reaction mixture. Greenish-yellow chlorine gas is evolved, which is detected by its pungent odor. This confirms the chloride ion. Click here to perform cation test. Perform the color test. The color of salt is white, so it does not belong to any of these cations. Perform dry heating test. Take a test tube, add 0.1 gram of salt to it. Heat the above test tube for about 1 minute and observe the color of the residue when it is hot and also when it cools. Since there is no change in color, it does not belong to any of these ions. Perform flame test. Take platinum loop dipped in salt paste and introduce the loop in the non-luminous flame. Observe the color of the flame. Here, color of the flame does not match any of the characteristic colors. Perform the borax bead test. Take the borax bead loop dipped in dry salt and heat it. Observe the color imparted to the bead in the oxidizing flame as well as in the reducing flame while it is hot and when it is cools. Here, bead color does not match any of the characteristic colors. Perform the charcoal cavity test. Take the charcoal block. It is filled with 0.2 gram of salt and 0.5 gram of anhydrous sodium carbonate in a freshly bored hole. Now bring it to the flame and heat the cavity with the bent flame and observe. Here, there is no change in color of salt. If the residue is of white color, perform cobalt nitrate test. Take the residue with added cobalt nitrate. Bring the charcoal cavity to the flame and heat it with the bent flame and observe. The color of the residue turns to blue, indicating the presence of aluminium ion. You can perform analysis of zero group cation to get accurate result, or you can directly perform the analysis of group of inferred cation in preliminary test. Take a test tube and add 0.1 gram of salt to it. Add 1 or 2 ml of NaOH solution and heat it. Since there is no smell of ammonia, this indicates the absence of ammonium ions. Perform next step. Take original solution in a test tube. Add dilute HCl solution to it. Since there is no precipitation, it indicates the absence of group 1 cation. Perform next step. Take aqueous original solution in a test tube. Add dilute HCl solution to it. Add water to it. Warm the solution. Pass the H2S gas to test tube using Gibbs apparatus. Since there is no change, group 2 cation ion is absent. Perform next step. Take a test tube and add original solution to it. Add 2-3 drops of HNO3 to it and heat for few minutes. After cooling, add a small amount of ammonium chloride and excess of ammonium hydroxide solution till it smells ammonia. A gelatinous white precipitate appears, which indicates the presence of aluminium ions. Perform confirmatory test for group 3 cations. Dissolve white precipitate in dilute HCl. Take test tube 2 and add half of the content from test tube 1 to it. To the test tube 1, add sodium hydroxide solution and heat it. A white gelatinous precipitate appears. Add excess sodium hydroxide solution to it. The precipitate will dissolve. To test tube 2, add blue litmus solution and ammonium hydroxide solution. A blue floating mass on the solution will appear, which confirms the presence of aluminium ion in the given salt. With this analysis, we can infer that given cation is aluminium and anion is chlorine.